Hi guys. So in today's class, we're going to talk about man-made fibers and their manufacturing process. So when we talk about manufactured fibers or man-made fibers, there are a few different types. The first one is regenerated fibers. These are fibers that are not synthetic because they're not synthesized completely, but we use materials found in nature and then manufacture them into fibers. So these are a little closer to natural fibers. Then we have the synthetic fibers. Those are completely synthesized materials, such as plastic chips or other polymers. And then there are mineral fibers like metal fibers, glass fibers, and so on. Manufactured fibers are usually produced by large companies. For example, if you produce cotton, it's usually produced by farmers, or sheep is similar, but manufactured fibers are produced by companies like DuPont, for example. These are big companies and they sometimes have different variations of the same fiber that has certain performance characteristics for specific end uses. If you're going to use the fiber for a certain purpose, for example, for firefighter clothing, they can actually create certain performance characteristics for that fiber. And in that case, they may register them as their own trademark. So in that case, you will see the R registered trademark symbol on the fiber. As an example, spandex fibers are produced by a lot of different companies, but if it is produced specifically by DuPont, it has certain higher quality performance characteristics, and it is called Lycra. Lycra is the registered trademark of DuPont for spandex. Spinning is the process used to convert the materials into fibers. So in the case of manufactured fibers, we call the process of making the fibers spinning. In the case of natural fibers, we call spinning when we are trying to convert the fibers into yarns. Okay. So how do we manufacture? There are a few basic steps in the manufacturing process. First, we have to create the raw material. This is the substance to form our solution. So you have to create a solution. The spinning solution is called the dope or the melt, depending on how you create the solution. And then we have to push that solution through tiny holes in the spinneret. And the spinneret is something that looks like a shower head. And this process is called extrusion of the fibers. And so we have those three processes, but then at the end, you have to create the solid fibers. So the first process is creating the dope solution. The second is extruding the fibers through the spinneret. So pushing that solution through the holes of that shower head. That's the extrusion process. And then the third step is turning the fibers into a solid state. So this can happen by coagulation, evaporation, or cooling. So here's the example. This is the shower head. This is an example of the shower head. It has those tiny holes, and you have the solution on top. We push the solution with some pressure, and that solution comes out of the holes. So you are creating the fibers like that, but this is still a solution. And for this to be a fiber, it has to become solid and dry. And to do that, depending on how you prepare your solution, you can use coagulation, evaporation, or cooling to make them turn into a solid state. So, for example, if you created the solution by melting plastic chips, and those solutions are generally prepared by using those chips, so you can melt the chips if they are synthetic materials or thermoplastic materials. And then that creates your solution. Then you push it through the spinneret. So what you need to do is you need to cool it off so that it can solidify. It's kind of like the way your nail polish dries. It's a similar process. So when you put nail polish, it's still fluid, but once it dries, it becomes solid. So this is kind of a similar situation with synthetic fibers. And sometimes you create the solution by dissolving it in a solvent, or sometimes you push the solution through a hole and it may come into a bath, like a chemical bath, where it dries. So some fibers do that. I mean, you might try that with nail polish. Maybe it will dry up a little bit in cold water, depending on the nature of the material. So this is the main manufacturing process. Now, because we are manufacturing it, it's man-made, we can actually create a lot of different cross sections. We are very flexible with these because these are not natural fibers. They don't come in the shape that they come in. We can change this, and the cross section depends on the shape of the holes on the spinneret. So if you have round holes, then you get round fibers. If you have a hole that looks like a little trilobe, then you get trilobal cross section. If you have a hole that looks like a triangle, you get a triangle cross section. So we have a lot more flexibility with these. We can change those. There are three most commonly used spinning methods. So the first one is melt spinning, probably the most popular one, especially for thermoplastic fibers. And thermoplastic fibers are fibers that melt. Those are heat sensitive, anything plastic. Then there's dry spinning. That is when we have to dissolve the solution in a solvent or dissolve the raw material in a solvent. And then there's wet spinning, where we extrude the fiber into a chemical bath. So melt spinning is used for nylon, polyester, olefin. You usually start with polymer chips like this. You put them in a big pot in a factory environment, of course, and you melt them, and then you push that through the spinneret to extrude the fibers, and you have to put some cold air or cool air on the fibers to dry them and coagulate them. These are polyester pellets. These are also going to melt, and it will be used to make polyester fibers. This is a schematic view of melt spinning. So you have your big pot here with the solution that you are heating up to melt. All the plastic chips are here, and then you have a pump that will push that with pressure, and then there's the spinneret here. The fibers come out of the spinneret, the cold air dries and coagulates the fibers immediately, and then you just wind them on a bobbin or on a package. This is melt spinning. And again, remember, melt spinning can only be used for fibers that are melting, that can melt, that are heat sensitive, that are thermoplastic. So anything plastic. So again, the shape of the spinneret head determines the physical shape of the fiber. These are olefin pellets. This can also be melted. Now, sometimes when they melt it, they also add a color to the solution, because some of these fibers are hydrophobic. They don't dye easily. So the easiest way to dye them is to dye them while they're still a solution, before they're produced as fibers. Dry spinning is used for acetate, acrylic, modacrylic, spandex, those type of fibers. Now you have your raw material, you dissolve it in a solvent, and then when the fibers come out of the spinneret holes, you have to evaporate the solvent so that the fibers become solid. So this is kind of how it works. The solution is pushed through the spinneret, the fibers come out, and you have hot air so that the solvent evaporates, and then you just wind the yarn on a bobbin. Now, when we are creating these fibers, you see that we have multiple fibers coming out of one spinneret, and all of these are put together to make one yarn. So this will be one yarn with multiple filaments in it. Now with dry spinning, because you are evaporating the solvent, the cross section actually changes because the fiber shrinks a little bit. So you do not get the perfect shape of the cross section that you get with melt spinning. Because with melt spinning, it really depends on the hole on the spinneret. These are spandex fibers. And then there's wet spinning. We use that for acrylic, lyocell, rayon, and spandex. This is a very old process. Fibers are usually weak in this case until they are completely dry because they are being extruded into a chemical bath. If you look at the process for this, this is our solution. We push this with the pump through the spinneret, and the spinneret is usually inside a bath, and the fibers come out inside that liquid or water. It's a chemical bath usually, and then you can wind it. You know, there are a couple different processes. You have to wash it out to get rid of all that bath water. And then it has to be dried out, and then you put it on a package. We do require washing and bleaching for wet spinning because of the chemical bath we are using. So it is a little bit more of a process. And the fiber cross section can also change a little bit because the fiber collapses in the chemical bath. So it's difficult to control the cross section with wet spinning. So those are the three methods. Okay, melt spinning, we melt the raw materials, push it through the spinneret, dry it with cool air. With dry spinning, we dissolve the solvent and we use hot air to evaporate the solvent to get the yarn. And then the wet spinning is we are extruding it into a chemical bath. And then cleaning, washing, drying the fibers and winding them on a bobbin. So some of the common characteristics of manufactured fibers, you can always change the fiber size just by changing the size of the spinneret. That's all you have to do. Fibers are inherently lustrous. There's a lot of shine to these because if you think of it as plastic type materials, there's always luster. And sometimes you have to add some delustrants to the solution to remove that luster because they can be a little too much. You can add additives to enhance the performance of the fibers, or you can add color pigments to dye. When we get those fibers coming out of the spinneret holes, each of those are called filaments because they are produced as long as they can possibly go. Sometimes we cut the filaments into shorter fibers, so we call them tow, filament tow, and we are cutting them into staples if we need to blend them with other natural fibers, for example, or you can also crimp them if you want them to look more like wool fibers. Some yarns will have multiple filaments in them, or you can have one single filament as the final yarn. It really depends on the product you're trying to create. There are things you can modify on manufactured fibers. You can't modify anything on a cotton fiber, on a flax fiber, on a wool fiber, but you can make changes to manufactured fibers because you can change the chemistry. Now, the polymer properties and physical structure can be changed to produce fibers that have certain physical characteristics or chemical characteristics. You can enhance performance. You can change whether you can wash it in the laundry or not. Polymer properties can be changed by changing the molecular structure or the arrangement of the molecules or adding additives into the molecular chain. You can change the physical structure, like the shape of the fiber, the size of the fiber, the fineness of the fiber, the color, the luster. When you have a polyester fiber, for example, and you want to create different variations of it, polyester would be your parent fiber, and then you create different variants of that fiber. If you want to change the size or change the shape of the spinneret, you will get different fiber sizes and fiber shapes. If you change the molecular structure or crystallinity, then you can change the durability of the fiber, you can change the tensile strength of the fiber. You can also combine two polymers and create bicomponent fibers. If you want to have really soft microfibers, obviously you need to have very fine diameters. Shingosen is one type of fiber that is an ultra-fine synthetic fiber that kind of has a silk-like look. Fiber diameter can be changed based on what your end uses. If you're going to use the fiber in clothing, you might need it less than 7 denier. If it's going to be used in interiors, it can be from 5 to 25 denier in size. In technical applications, it may be any size depending on what you want to do. And micro denier is generally less than 1 denier per filament. We may want to change the shape, the cross-section shape of a fiber. And we do that for certain purposes. For example, if you want the fiber to reflect light, give it a sparkle, then you want to make that flat. If you want to hide dirt and soil, then trilobal shape is the best for that, especially for carpets. This is a good shape because of those three lobes you have. The dirt and hide usually hides inside, and when you make the carpet out of those type of yarns, you never see it on the surface, so it hides dirt and soil. That you can also make them quadrilobal, pentalobal, with 5 lobes, 6 lobes, whatever you want to do. And you can make them in this kind of cross section that looks like a pie wedge. If you want to keep yourself warm, you need to have some hollow fibers in your garment. So if you want to have a winter coat, for example, hollow fibers are really good because they do trap the warm air and they keep you insulated and warm. These are rayon fibers with a flat cross section. And rayon looks a lot like cotton, or feels a whole lot like cotton, but it has a lot more luster compared to cotton. These are nylon fibers with hollow cross section. These are also hollow, and these are also hollow. So depending on how you want your fabric to perform, you can make changes to these. If you want to make fibers that have high tensile strength, then what you do is when you are producing the fiber, you can draw or stretch the fiber. That way, all the molecular chains will become more parallel, and that will increase the tenacity or tensile strength of the fibers. So if you want to do that for better abrasion resistance, this is probably a good way. But if you want to prevent pilling, then you do the opposite. You want weaker fibers, because when you have weaker fibers, they do break easily and they don't create pilling. They don't just stay on the surface of the fabric, making a little ball. If you decrease the molecular weight, that decreases the tensile strength. And then when the fibers are trying to ball up on the surface, they easily break and fall, and you prevent pilling that way. You can make low elongation fibers or extra elongation fibers. So there are a lot of things you can do to reinforce these fibers and create like those type of modifications. Shape memory fibers, those are smart textiles that change shape when they're exposed to some kind of stimulus. High tenacity fibers, you can produce them also by increasing molecular chain length or the degree of polymerization, or by stretching the fibers or by drawing the fibers so that the molecular chains are more parallel. You can also modify the molecular structure if you want low melting point fibers. If you want the fibers to melt at low temperatures. Or if you want to increase the dyeability of the fibers, you can change the molecular structure. If you want to have flame resistant fibers, you can alter the composition of the fibers. So there are a lot of things you can do. You can add additives like the lustrants to make them less lustrous. You can add color pigments. If we add those color pigments when it's a solution, we call it solution dyeing. These are solution dyed Nomex filament yarns. You can see a lot of luster on this right here. Natural fibers don't have that kind of shine. So usually if you see that, it is definitely not a natural fiber. This is Nomex yarns. This is an aramid fiber. Nomex is the registered trademark by DuPont because this is produced by DuPont. There are other additives you can add like whiteners, brighteners, anti-static fibers. By adding certain additives, you can make sunlight resistant fibers, flame retardant fibers, antibacterial fibers. So all of that can be modified on manufactured fibers. You can crimp the fibers, which means you're creating waviness on the fiber. And sometimes that's necessary if you're trying to make the fiber look more like wool, or you're trying to resemble wool, or trying to make blankets, bulky knits, and so on. There are also bicomponent fibers where we have two polymers that are different, but we are extruding them through the spinneret together, and that creates very different characteristics on the fiber. So this is an example of that. Let's say this is your hole, and you have two different polymers, and you're pushing those two separate solutions through the spinneret, and your fiber will have a cross section where half of it is polymer A, half of it is solution B. So you have that kind of fiber. Or you can create a cross section like this by arranging the solution in a different way. So this is called a core sheet. This is called side-by-side arrangement. So these are different cross sections of bicomponent fibers. Performance fibers are used to enhance human performance. Sometimes you add moisture absorption or wicking properties or insulation, or you make them waterproof or lightweight, or you're making them microfibers. So there are a lot of different characteristics used for specific applications. There are a lot of environmental hazards, of course, when you're producing manufactured fibers or man-made fibers. First of all, the raw materials are usually, especially for synthetics, it's petroleum sources. And those are not renewable and they cost money. Sometimes you can have hazardous chemical spills. Recycling can be done, but usually those type of materials don't compost in the nature. There are health and safety issues when you work in a factory that produces them. If you're making regenerated fibers that are using wood pulp, then you're harvesting a lot of trees for that. So that's also not good. You have to dispose the waste and so on. So there are a lot of negative impacts to the environment when you make manufactured fibers. So to compare natural versus manufactured, natural fibers are only produced in certain seasons. You can't just make them whenever you want, but manufactured fibers can be produced continuously. Natural fibers will be very different based on the weather, the nutrients, the type. So if you're producing cotton, it really depends on the weather and how you harvest. But manufactured fibers are usually very uniform, and you can make them all exactly the same. The physical structure of natural fibers depends on the plant or on the animal source. The physical structure of the manufactured fibers depends on the fiber spinning process and all the treatments or additives. The chemical composition will be different for different natural fibers. For manufactured fibers, it will depend on your starting material. Natural fibers are mostly staple. Manufactured fibers can be any length. Natural fibers are not as versatile because you can't modify them, you can't make changes to them, but manufactured fibers are very versatile. Natural fibers are more hydrophilic, more absorbent. Manufactured fibers usually do not like water so much, and absorbency can be improved, but it really depends on the chemistry. So if you think of it as plastic, they don't really absorb moisture too much. So you can make some modifications to it if you want, but it won't be like natural fibers. Natural fibers are not so heat sensitive. So if you want to iron a linen material, you can go all the way up on the highest temperature on your iron. But for manufactured fibers, if you use the same temperature, you're going to melt your fabric. So manufactured fibers, many of them are heat sensitive, especially thermoplastic fibers. They will melt if you put too much heat on it. The natural fibers, the size depends on the type of the fiber and the variety, but manufactured, you can actually change the size. It's all up to you. I'm going to go to your iTextiles a little bit and just show a couple different things that I haven't mentioned. One thing is there's also rubber. I didn't mention this is also usually manufactured. Rubber can be made of natural rubber or there's synthetic rubber. The regenerated fibers are the fibers that use an organic or natural raw material. So some of those raw materials, those are usually cellulosic. Some of those come from trees like eucalyptus trees or bamboo trees, soybean, milk, those are some of the raw materials to make regenerated fibers. If they are coming from plants, they're usually cellulosic. If they're coming from food, they're usually protein-based. For synthetic fibers, the raw materials are usually pellets, plastic chips, bottle chips. You can use plastic bottles. You can cut them up into pieces and melt them and create yarns out of them. You can also use used garments and recycle them to make those synthetic fibers. Thermoplastic fibers, these are synthetic fibers like acetate, triacetate, nylon, polyester, olefin, acrylic. These are fibers that melt and they have certain characteristics. You can crimp them, you can heat set them. Heat setting them is creating them in a certain shape and keeping that in that shape. For example, you can create permanent pleats on a fabric if it is thermoplastic. You can seal raw edges. There are a lot of things. You can thermally bond fabrics, fibers that melt. The heat setting is, for example, you have this fabric. If it is flat, it's going to look like this. So all the molecular chains have certain bonds. But then you change it, curve it up like this. In that case, you are distorting the fiber, but when you heat it, then these bonds will loosen up, and then you're going to create new bonds. And then when you cool it off, it stays with those bonds. So the shape of the fiber will stay like this. It will stay bent like this. And this is called heat setting. So you're using heat to change the shape. You are never heating it up to a point where it melts. You are always below the melting point, but you get to a point where those bonds will loosen up. And once they loosen up, you keep it in that shape and then you start cooling, then those new bonds will just stay permanent and keep the shape of the fabric like that. This is another good picture of a spinneret and the filaments coming out of it. So usually when you see that many filaments, those filaments will be really, really fine, and then they are put together to create one yarn. I'm gonna finish it up here, and I want you guys to make sure you complete your little test that's going to be on Blackboard.